Hi, in this video I will show you how to use AI to easily ask questions about items listed in different product catalogs and get meaningful insights and detailed information. But to do that, first your data needs to be in a structured format, meaning that individual products or product variants are neatly organized in a table which can then be easily processed. Like this table, for example, which holds information about different gardening products. In reality, though, that's often not the case. So, to get to structured data, we may first need to do some pre-processing. At the end of this video, you will find a link to a tool that does exactly that. It helps you extract data from PDFs or spreadsheets into a clean, structured format. With the advancement of AI, tools like Llama Index Extract or Agentic Document Extraction by LangGraph do an amazing job parsing and extracting data from documents. And these tools are only going to get better. Once you have the structured data, you can use this product catalog assistant, and the best part is that you can just open the Colab link provided below this video, upload your files and run it right away. No need to deploy anything or pay for no-code tools subscription to automate this process. All you need is a Google account and OpenAI API key. Or if you switch providers in the code, then the API key for your chosen LLM. In Colab, the API keys are provided in the secrets menu here on the left. Another great feature of Colab is that you can ask Gemini to explain the code in each cell. Let me show you how this is done. It's done over from this menu here. This is especially helpful if it's your first time working with an agent or if you'd like to better understand the code. Now let's take a look at how the agent works. First, you need to pass in Excel files containing product data you'd like to analyze. These files don't need to have the same structure. They can have different columns. That's totally fine, and the agent will handle it. In this demo, I'm using synthetic data, so my spreadsheets look similar, but it doesn't matter for the tool. So my spreadsheets look very similar because an LLM generated them. But it doesn't matter. In Colab, to upload your files, it's best to first create a folder. This is where you create a folder, right-click, new folder, and then once you have the folder, you can upload your files from the three dots menu here. I have already uploaded my files here. You can see them. Once you have done this, you must pass the full file path to the agent. So you must pass the path, first the folder name and then the file name. Next, you can ask your question here in the user input. And then you need to specify a search result count as well. The default is 10. This number tells the agent how many product entries to retrieve from the database based on your question. You can play with this number to see how it influences the results. Then an LLM reviews those retrieved entries and extracts only the ones that are truly relevant for your question. This means that the final answer might include fewer entries than the number you have originally set here. Once you provide all the inputs, you can run the cell, or if it's your first time running this agent, you can execute all cells using the run all option from the runtime menu here. Here is what the agent does then. Let's take a look at its graph. It first checks whether the provided files have already been processed and stored in the vector store. This is done by this first note here. If they have not been processed, it extracts the product data row by row and embeds it into the database. This is done by those two nodes, first the extraction and then the embedding. If the files have already been processed, the agent skips straight to retrieval, pulling relevant product entries based on your query. Then it passes, the retrieval is done by the search node, and then it passes those results to the LLM, which answers your question using only the data from your catalog. No hallucinations and no guessing. I will run the agent now for the first time and then again, so we can observe how it behaves in both cases. After that, I will walk you through the agent implementation once again. Let's run this agent from this cell because the dependencies have been already installed, and check how it behaves. My question is, compare vegetable planter prices based this is my second question, but we can start from this one as well. So we have already, I've seen in my first question that there are two providers which I want to compare the prices between. So we have these two planters and the prices between the two providers compared. And now let's look at how the execution went. It started from it passed through extract product node because it found two unprocessed files, and then it embedded the content of each file, and then it retrieved the number of search results, which has been 15, and based on my input, it processed all of those 15 retrieved entries and defined and found those two as relevant for my question, and this is why I see only them. Let's try now to execute this other cell, this other question, and let's check how it will behave in this case. It says all files already processed because this happened already, and the question is, give me vegetable planters suggestions and order them by catalog price. So with this question we can see that there are much more entries, many more entries are retrieved, and because I have very similar data in my Excel files, it has retrieved the 15 matching entries, but because I have limited it to 15 search results, but in fact I have some more data which is related to planters in those files, and if I give it a higher number, then it will retrieve more because they're very, very similar, since it's the generation more or less generated the same data. Let's try with 30 and see how many will be retrieved then. Again, it is skipping extraction because this has already been done once. And now we will see how many entries there will be. If there are more than 30 planter entries, then we will hit the 30 number. So now it's all together, there are obviously 23, starting from 0. And they are all ordered by sorted by price, as I have asked. Now let's take a quick look at how the agent is organized. At the beginning, I'm installing the dependencies which I needed for this agent creation. Then here is passing the API key. Then this is the vector store initialization, and then I create the agent state. If we check what Gemini will tell us about it, we will get this feedback. This class is crucial for managing the flow of information within a large system like a workflow or an agent powered by the LangGraph library. It acts as central repository for data that needs to be shared and updated as the workflow progresses through different steps, and you will get the explanation for all the entries for all the parameters in the state. In summary, the agent state class provides a structured way to manage the data that flows through the smart product catalog assistant, and so on and so on. This feedback here is or explanation is very helpful if you want to get into the details of how the logic in each node is organized. Going forward, this is maybe the most interesting node. It is the answer node, where the LLM is being given instructions on how to behave and how to process the information it has been given or passed from the search. You are a helpful assistant that receives a natural language user query and a list of product data entries as JSON dictionaries, and then it is guided through how it should answer the user question. Then here is where the agent graph is built. All the nodes are defined, the transitions between those nodes, which are called edges. If you want, you can uncomment this line here and also print an image of the agent graph. And finally, there is the run agent function, which enables you to execute this agent. That's all for the Smart Product Assistant, and if you are interested, I can share a version of it that compares product information from websites you provide or from your product catalogs against competitor websites. Thanks for watching.